Hello, this is Latifi. So our project is Optiver trading at the close. Uh, yeah, next slide, please. So this is our agenda. We have worked on these aspects as an agenda. Next slide. Yeah, so for the introduction part, this project aims to predict the closing price movements in the last 10 minutes of Nasdaq stocks using Optiver's Kaggle dataset. So the last 10 minutes are crucial as they determine the final closing price. So accurate forecast can enhance the investment decisions. Next slide, please. Yeah, so this is our team. The team consists of 5 members covering the machine learning, development, and project management parts. So each member played a vital role based on their specialization. Yeah, so understanding the data set contains over 5 million rows covering 200 stocks over 2 years. So for each stock, the day last 9 minutes of the data is provided. So this allows the model to leverage the price patterns and everything. Yeah, next slide, please. Yeah, so for the project scope, the project objective is to develop the ML models to forecast the price changes in the last 10 minutes. So the Optiver dataset includes stock identifiers, dates, order details, and closing prices, everything. And advanced techniques like LSTM, ARIMA, and are applied and evaluated. Yeah. Next slide, please. Yeah, so these are the methods we worked on, like time series models like ARMA and LSTM are applied. So traditional ML models like random forest and linear regression are tested. So key evaluation metrics are mean squared error and mean absolute error are used for performance metric evaluation. So the next slide will be covered by my teammate Azim.
Hi, thank you, Latifi, for the brief introduction. This is the architecture, the whole architecture of our project. Basically, we had the data set as described by the Latifi in the before slide. We did few data pre-processing than that, and then we had transformed the stationary, the non-stationary to the stationary by different means like differencing and lagging. And then we selected various time series models, which will be discussed in the further slides. And then we have splitted the data into training and testing, and then evaluation had been performed. So once we have trained the model, the evaluation had been performed, and later it had been gone to the deployment side. The next slide will be covered by Farhan Bhai.
Hello, my name is Farhan. So I'm going to discuss about ARMA, which is an autoregressive moving average model. So the ARMA is used for time series prediction. The challenges are only in this data set. Usually for time series, we need about 100 data points for a good prediction, but in this data, we had only 54 data points, and there was no seasonality, and data is not stationary. Next slide, please. So this is the forecast of stock 17 using ARMA model. For the parameters P, D, and Q, we use 3, 0, and 3. 3 for autoregressive and 3 for moving average. The error metrics, we have seen that this is a good model because our directionality error is 0.107 and our mean absolute error is 9.124. We have used other two metrics. We have also used other two metrics. Next slide, please. This will be covered by Avijit.
Hello, I am Avijit. So I worked on LSTM model. LSTM is a long short-term memory. So in this model, we all know that LSTM is used for time series analysis and forecasting. So in this, I use input layer as 50, and the shape is 1, 3. The 3 is a sequence length. I use 3 previous point to predict the current position or current value, and the output layer is 1. So I use as a performance metric, I use mean squared error, and for Adam optimizer, I use learning rate at 0.001, and the mean squared error for this stock I work on is 142. The mean squared error is 0.96. Next slide will be covered by Azim.
Yeah, this model is this ARIMA. This is the seasonal ARIMA. So this we had used ARIMA at the beginning. So to provide a continuation of that, I just tried it, but we failed to perform a proper prediction in this. So that's the graph which shows that it's like a false prediction or something like that, and even the high error metrics. I mean, the performance measures is very high in this. So we just dropped this and we just moved to the further algorithms. Coming to the next slide, we have a few regression models that will be covered in the next slide. Next slide, please. Yeah, this is the random forest which I had done. Like What I have done is like I have divided the data set of 9 minutes into 8 minutes and 1 minute. The 8 minute is being for the training and 1 minute is being for the testing. So as you see, the first 8 minutes in the diagram, when I forecasted the stock 135, the first 8 minutes is like the first 48 data points is for the training. The remaining is for the testing. As you can see that it shows that the prediction is very good. Even the mean square error is lower, and we has used n estimators and random state, 2 parameters we had used for training this particular model. So the next model, which is linear regression, that will be covered by Shivani.
Hello everyone, this is Shivani. So we have used the linear regression model to predict, to forecast our values. Here I divided the trading set into 8 minutes for training and 1 minute for testing. And we have used the lag features, lag features 1 to 10 to test which lag feature would be giving us the best values. And we found out through different metrics that lag 1 will, for linear regression, will give the best prediction. Next slide, please. So then we tried to use an ensemble technique by using a random forest and ARIMA ML model and a statistical model to see if it will give a better result. But we couldn't conclude which one was better. Here is a graph showing the MSC comparison between ARIMA ML and the combined model. But we can see the combined model had overall less mean square error related to others. Next. So in the last, we have used a support vector regressor. We have implemented it using different kernels. So the one on the left is the one is with linear kernel. It didn't fit well compared to the polynomial kernel, where the MSE has decreased significantly. And we also have performed some hyperparameter tunings and found out that the polynomial kernel gives the best results. Next. Now this will be explained by Latifi.
Yeah, so I worked on machine learning aspect focusing on stock 138. So I tried with doing the selecting the values of PDQ. So I got these results and I got the mean squared error as 135. So I did the evaluation and thorough actively using the performance metrics of this. So after that, we got these values. So I tried the data visualization and data pre-processing and feature engineering part for this model. So we did this. So next slide, please. Yeah, so for each stock, we did the Dickey-Fuller test, ACF and PACF, we got these values. So for this stock 138, we got the ADF as negative value. So we can say that this is stationary. So for all the stocks, we got the stationary. Next slide, please. Yeah, so this is the ARIMA model prediction for stock 138 at 9 minutes. So we can see that analyzing results for a stock 138. So it demonstrated the amazing precision in capturing the price dynamics in the 9th minute. So it is the insightful information for prompt decision making. So for the performance evaluation, a careful analysis of the model's prediction and the actual closing prices showed a satisfactory level of acceptance that suggests the model was effective in predicting the behavior of stock 138 over this particular time period. So next slide will be covered by my classmate.
Next slide. So these are the results. So we use the mean absolute error, which will be used in the Kaggle challenge to compare our models. And this is what we have gotten. You can see that LSTM has the least mean absolute error. And these are the 3 models we use to deploy. Next slide. The achievements will be explained by Farhan.
Hello. So for the achievements, we have implemented the project and implemented advanced statistical machine learning and deep learning models. We have successfully deployed a web page, and we have used innovative approach. And yeah, that's all. Next slide, please. So the challenges, as we have discussed earlier, there is a limitation of data points for each stock, and there is excessive domain specific challenges, and the problem statement is highly complex, and we had to use advanced models like ARIMA and LSTM. Next slide. So from here, it will be explained by Abhijit.
Hello everyone, hello again. So I worked on the deployment. So for the deployment, we use Heroku, and for the first at the first step, we create a Heroku account. We set up the deployment pipeline for all the models, and from our branches, we directly push and deploy our project. This is our project. Let me go through the demonstration part. So in this, this is our deployed version. So in this, we are taking the input from the user, input the stock ID and day, as we are working on each day. So let's go to this. You can see that for this prediction, we can find the LSTM, and this is the ARMA, and this is the support vector regressor. So in this, we can see the results for every model. Let's move on to different stock and give a different input for that. So in this, we can see this is our mean absolute error for LSTM. This is for ARMA, and this is for support vector regressor. So this is our demonstration for this short demonstration for the project. Next, for the resource we use Heroku, and for collaboration and version control we use GitHub, and there will be recording will be added soon. Thank you everyone for your time. Thank you.